Hello class, today we're going to finish our last section we're covering in chapter 7, section 4, parallel lines and proportional parts. Our objectives today are to use proportional parts within triangles and to use proportional parts with parallel lines. So let's get started. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So if I have not B. Let's start with A. If I have A and I have a line and it intersects at B, and here's C, D, and it intersects at E, and EB is parallel to DC, then I'm going to have some proportions. So if BE is parallel to CD, then the portion AB is proportional to BC. So that's this top portion here and this portion here are going to be proportional to AE and ED. So the sides on the other portion of the triangle. So let's go ahead and look here. In triangle PQRS, ST is parallel to RQ. If PT is 7.5 and TQ is 3 and SR is 2.5, find PS. So all we have to do is set up a proportion, and we are used to doing these from our similar polygons and similar triangles. So my 2.5 is going to match up with my 3, and I'm going to put the x with the 2.5 because it came from the same side. So I put a 7.5 down here. We're going to go ahead and cross multiply. 2.5 times 7.5 is going to give us 18.75. Divide that by 3, and we find that PS is 6.25. All right, so in the same way, we have the converse. If a line intersects two sides of a triangle and separates them into proportional corresponding segments, then you know the line is parallel. So first we saw that it was parallel and it broke it into proportional parts. And here, if we have proportional parts, we're going to know it's parallel. And so I'm just going to show you guys the line again so that we know what we're referencing. So if we have proportional parts, so if DE and EA are proportional to CB and BC, then we know that DC is going to be parallel to EB. All right, so let's take a peek here. In triangle DEF, EH is 3 and HF is 9, and DG is 1/3 of the length of GH. Okay, so DE is this portion here. So we're going to have 1/3. Oh, DG, sorry, not DE. DG is 1/3 X, and we are supposed to have, oh, that's supposed to be a GH. Sorry, guys. So that's going to be X. There we go. That's why my symbol is all thrown off. Okay, so let's set up our proportion. And if these are proportional, then we will know that that DE and GH are parallel lines. All right, so I'm just going to have 3 and 9. And 1/3 goes with the 3 because they're both the smaller portions, and X goes on the bottom. And if I look here, I can see an easy simplification. I have an X in the top and an X in the bottom, so those cancel. So we have 3/9 equals 1/3. And so yes, this is proportional. So if it's proportional, then DE is parallel to GH. All right. Let's introduce midsegment. The midsegment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle has 3 midsegments. So we saw midsegments with isosceles trapezoids, where if we have these midsegments, or these midpoints, this becomes our midsegment. So that means that these two sides will be congruent and this side will be congruent. They're not congruent from one side of the triangle to the other. That would make this that wouldn't make this a midpoint, but, and we're going to put in one more and draw that there and that one there. So then these two sides are going to be. All right, so we've just broken our triangle up into 3 midpoints, which gave us 3 midsegments. So our triangle midsegment theorem says A midsegment of a triangle is parallel to one side of the triangle, and its length is half of that side. So if we look back and think about our midsegments, so if we have midsegments here, so congruent pieces, this point here is now become our midsegment, and that is going to be parallel to our base. So let's say here, if J and K are midpoints, then JK is parallel to FG, so that midsegment's parallel to that base, and we know that JK, our midsegment, is half of that base. Now, we saw it once here, but if we go back here to this diagram, we could say that this side is parallel to that side. We can go ahead and say this side is parallel to that midsegment, and then our last one is going to be these two midsegments are parallel. All right, so let's go ahead here and look at problem 3. So in the figure, XY and XZ are midsegments of triangle RST. Find the measure of each. So I'm going to go ahead and get you started with XZ. So I know XZ is going to be half of RT because those are going to be my midsegment and my base. So I can say that XZ is half of RT, which is 13. So therefore, XZ is 6.5. All right, I want you guys to try B and, try C. It deals with some parallel lines and some angles. All right, see here. Problem 4 looks like this one. Given IJ is the midsegment in triangle FGH. Okay, so IJ is a midsegment, so that means these two portions are congruent and these two portions will be congruent. Find X and Y. Well, X is easy because we see we have two congruent sides. Okay, so find that for X. And then we see our Y. Well, our Y is going to be here in our midsegment and our base. So we remember our midsegment is half of our base. So we can times our midsegment by 2 or divide our base by half and set them equal to each other, and that'll help us find Y. And then we again have some angles with parallel lines. So have those done for tomorrow and give problem 5 a try. Not too difficult. All right, we'll see you guys then.